Please pause the video and take a moment to read this important safety message. Hey, welcome everybody. Hopefully another fun and educational video here today at Blue Glow Electronics. What we've got on the bench here today is a McIntosh MX110 preamplifier over here on the left. And just for bench purposes, I happen to be using just a single-ended KT88 amp over here at the Dennis Hat Inspire as just my bench amp. I like to use it because it's relatively small and doesn't take up a lot of bench space. At any rate, this video really isn't about either one of those pieces of gear. It is about troubleshooting a vacuum tube amplifier or preamplifier or whatever piece of equipment power supply. Okay, I just happen to be using an MX110 in this scenario. So let me show you a little bit of what we've got going on here. Alright, this is an MX110 unit that I picked up about a year ago off a gentleman in Winston-Salem. It was one of those stories where he had found the unit, sent it to me to do a full restoration. I did the full restoration. He used it for a while, then he decided he wanted to get back to solid state gear, and basically reached out to me and asked me would I be interested in purchasing this along with its accompanying MC240, and I said yes. So I ended up with both of these units, and then I was cruising Audio Carmel one day and I saw a gentleman on there basically saying want to buy McIntosh MX110 at a reasonable price, and he had kind of this price point in mind, somewhere around $1,000 to maybe $1,300, and this unit is cosmetically not perfect. It's probably a 7 out of a 10. Did the best I could on it cosmetically. Ended up putting a new dial on it from radio days, kind of cleaning it up well, switching it over to LED lights, and then I did a full electronic restoration and replaced a few tubes on it, was the short and narrow of it. But any rate, he ended up selling it to him and separating it from its lost partner that's in the other room over there, and shipped it off to him, and all went well for several weeks. The gentleman played it, absolutely loved it, said it sounded great, was extremely happy with it, and then all of a sudden one day he was listening to it and it started making this humming sound. And so he played around with a lot of things. He reached out to me. I had him go in and reset all the tubes just to make sure it wasn't something that maybe he could solve himself. That didn't help, so he ended up shipping it back to me, and now I've got it on the bench and going to figure out what's wrong with it. So let me switch over to a top-down view. Just a quick run through of what I did for the electronic restoration. I replaced all the coupling caps in the unit here, as you can see. I guess there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then some up front. 10 or a dozen coupling caps in the unit. I replaced some resistors that were out of spec. We rewired, this had a selenium rectifier in it, and we replaced that with a little tag strip here and a solid state rectification setup. We replaced some electrolytic capacitors, and we replaced all the can caps inside the unit, these 3 here on top, with brand new ones. And then we also went through and aligned and adjusted the unit. So at this point, it was a beautiful, fully functional unit when it went back out the door. And then I got it back, and you know, let me let you hear this hum. All right, I'm trying to get a view here where you can both see the. All right, I'm gonna turn the volume up on it. Okay, and that's with no inputs. So even though I've got a little iPod here on my desk hooked up to a set of RCA jacks that are not plugged in right now, and as you can see here, I will plug these in, and it will make absolutely no difference. So it's nothing on the input causing this, it's something within the unit itself, okay? So let's just say you had a little bench setup at home, maybe you had an oscilloscope, and you were listening to this through your speakers, and you said, well, I've got hum no matter what I do, whether I put it on FM, whether I put it on aux, phono, regardless of the input, the same hum. Okay, the next thing you're going to try to figure out is, what kind of hum is that? Now, I'm running a setup here where I'm basically feeding the output of this unit, the speakers, up inside of a dummy load box here that's got two 8-ohm 250 watt resistors, and then right now I've just basically got it flipped down on speaker. So the output of this is just basically going up through these banana jacks into this unit, getting switched out over here, and then I'm feeding out of this unit over into, you can see here blue and red, just feeding into my oscilloscope. So I'm able to measure that. Interestingly, you notice the oscilloscope right now, and I'm measuring across the speaker outputs. I'm really not seeing a lot here, okay? I want you to watch this, okay? The second I flip it over onto off of speaker and onto dummy load, where I'm actually measuring across an 8-ohm non-inductive load, and watch as I turn the volume up here, okay? You can really see, if you look at it right there, that's a 1/2 volt of hum sitting on top of our output going to the speakers right now, which is exactly why you hear this noise, okay? And we don't want that. So the next thing you're going to want to try to figure out, let's diagnose this signal a little bit. Now, two ways to go about it depending upon the type of scope you have. Right now this unit's set on 2 milliseconds, and I could have read that if I had an older scope that wasn't digital. Could have read that off the selector switch, and then I could have measured 1, 2, 3, 4. I could have done the math on that. 1 over time would have given me the frequency of this unit here. But if you got a digital oscilloscope of any type, you should be able to measure, and I'm going to click time here, and I'm going to do the same thing, 1 over seconds, and then I'll just move my little cursor here to it's on the bottom here, and then the bottom of that one, and if you'll notice, you're measuring them what is called the period of this waveform, and right here, what does that say? It says 120 hertz, okay? That tells us that this issue we have is post-rectification. Okay, so it's not 60 hertz line noise causing you a problem. It's not like you've got a power line inside of this too close to maybe a signal line and it's picking up 60 hertz hum. It's probably not coming from a fluorescent light nearby. It is a rectified signal inside of this that is not being cleaned up very well before it's getting sent on through the rest of the amplifier. Okay? So what did I do next? Well, I did what any good troubleshooting technician would do. I downloaded a schematic of the power supply here. And this power supply in this unit is more complex than most, but not, if you break it down, it's not that bad. You've kind of got the primary of the power transformer here, and then you've got multiple secondaries here, right? This set here, which has a center tap on it, is being used to feed the high voltage section up here, and it's kind of split off. You've got one section here for this 85 volts, and then you've got another rail over here where you're feeding 230 volts, 180 volts, and 160 volts off of that. You've also got another section here, right, where you're feeding out, and basically what you're feeding are filaments on tubes. And in this case, these filaments, if you'll notice here, they have kind of a center tap of them going off to this 85 volts. And so what they're kind of doing is floating these heaters here above ground. Could be several scenarios that might have caused them to want to do that, ultimately leading to noise reduction and or avoiding the grid to cathode voltage ratings. By voltage rating issue, but nonetheless they've done that here. And then you've got another set here that's feeding through some other filaments, and then your last one down here is kind of feeding some more filaments and some dial lights on this unit. So nonetheless, I just wanted to go through and make sure, one, that all my filaments were lighting up, and I did that by using just a plain old handy dandy multimeter set on volts DC, and I started measuring across some of the tubes here. All you got to do is pull up a pin out for a 12AX7, find you a 12AX7 in here, there's lots of them, and start measuring across that, and you'll quickly find that you've got voltage across your filaments here. So most of this is going well. Then I just wanted to find this 85 volt source, this 160, the 230 and whatnot, and make sure those were intact. And I did that same thing. I pulled out handy dandy multimeter, You know, I clipped one end here just to the chassis somewhere, like right here, and then the other one I just kind of went around and found these locations and tested for voltage. The good news was the power supply is actually working and providing the voltages that it should throughout this unit. If it wasn't, then maybe you would want to start looking at, maybe I've got some bad rectifiers here. Potentially you could have something shorted along the way. You possibly could have a problem with your power transformer. And I did all that, and I really wasn't finding much of anything wrong with this unit at that point. So I spent quite a bit of time really going through double checking all my work I had done before, you know, making sure that I didn't have any cold solder joints anywhere. I really went through each and every one of these connections to these new CAN capacitors well. I found a section right here where it wasn't quite as clean as I would like it to be, and so I ended up unsoldering things. I kind of stripped these wires off and redid this, but to no avail. It really didn't change anything. Still got this hum noise. I also checked voltages back here on the rectifier just to make sure what I was getting out was right, and lo and behold, I'm getting the voltages I'm needing to. Everything seems right. I went through even the painstaking of making sure everywhere in this unit that nowhere maybe a component lead had been shorted to ground. Didn't find anything there. I also made sure all my ground wires feeding to capacitors like these and these, that they were both connected here and wherever else they were going in this unit. Because if you end up floating one into the power supply by not grounding it, you could end up with some hum like this. And so I'm just kind of going through the unit, and I'm really not finding anything. And so I thought, well, wow, where am I going to go next? So I thought to myself, well, you know, an old trick I've seen done before, and I've done. I kind of dreamed it up and thought, well, let's go down this path. So my deductive line of thinking at that point was then possibly, just possibly, some of these brand new components that I installed have possibly gone bad. It's not often you see that, but you never know. So, and one thing about a capacitor, okay, you see this capacitor, you know, kind of bolted in here really strongly. The negative here is tied off to ground, and then you've got 4 sections to this cap. And typically what you're doing in this scenario like this is just like this. You're kind of coming off of a high voltage point, and then you've got a capacitor section. And then you're feeding across a resistor here to another capacitor section, then across the resistor to another power section, so on and so forth. So that by the time you get to the 4th segment or so of this unit, you've dropped voltages along the way, and you've got a nice clean here what we'll call a CRC network, and then a second CRC, a third CRC, a fourth CRC. And so, you know, I'm thinking about the fact I've got my voltages I want, but I've got this hum that's 120 hertz of rectified signals sitting on top of it. So possibly one of these capacitors is not doing their job very well, okay? So up next, what I did was powered the unit down, grabbed a handy dandy discharge wand. And by the way, if you haven't seen my video on how to make one of these, super simple, and it's a fun little afternoon project. At any rate, I powered this unit down, and I'm going to go through now and I'm going to discharge these capacitors really well all the way across the board here, just to make sure that when I go playing around in here, here in just a second, as you'll see, I'm not getting zapped along the way. At any rate, what I did was I flipped it over and I looked at the values of these CAN caps. Now this one's a little different. This is a 2000 microfarad times 2. Both of these here in essence have around 50 microfarads. Some of them are 40, some of them are 60 or whatnot, but around 50 microfarads on each of these sections. So what I did then is I went into my workshop and I dug up a brand new Nikon 47 microfarad at 450 volts. Now this isn't a repair capacitor right now. This is a testing capacitor to try to prove out a point, okay? And so what I wanted to do then is I want to take this capacitor and I want to take the negative lead of this, okay? And I'm going to kind of solder it off here, and I'm just going to put a little solder on on my tip here, and I want to solder it off onto and tie it onto wherever the negative of this capacitor is tied off onto, right? And then what I'm going to do is I'm going to grab, this is a high voltage 600 volt rated banana plug connector here with an insulated alligator clip on one end, and I ended up putting an insulated alligator clip on the other end. But basically what I'm going to do is clip one end of this onto the positive here and make sure it, it doesn't, as it leans over or whatnot, the weight doesn't touch anything there, okay? I'm going to power the unit back on over here, and I'm going to flip to full view here so you can see the scope at the same time. Okay, then what I'm going to do is take the other end of this and please you're playing with high voltage here, so I'm not recommending this for everyone. I'm recommending it for a more advanced technician. And you will get a little spark as you connect this onto the first section of a capacitor, because you are actually charging up that capacitor there. Well, I've hooked onto the first section of this capacitor and nothing really changed here. So why am I connecting this in parallel with that section of the capacitor? Well, if you know anything about capacitance, remember when you put capacitors in parallel, what do? They add, okay? So let's just say that section of that capacitor had gone bad, and it was, instead of being 50 microfarads, it was only 2 microfarads, and thus not filtering well, causing an issue like this. Well, when you take 2 microfarads and put in parallel with it 47 microfarads, guess what you get? You ended up with 49 microfarads, which is pretty close to what we should be seeing to get rid of this ripple. But apparently that's not the problem. That section of the capacitor is not bad. If you'll notice, I have my other hand in my pocket over here. You probably can't see that, but I'm just moving around, kind of connecting to the different sections here. And as I move through all 4 of those here, and I'll clip on the last one here, I'm just not seeing anything. That popping noise you were hearing is actually this capacitor recharging each time that I'm connecting it. I'm not actually shorting anything causing that. But that didn't solve the problem. So what are we going to do? I'm going to power this unit off. Okay, I'm going to disconnect this end. I'm going to disconnect this end. I'm going to use my discharge wand again. I'm going to go through and discharge all these, especially the one I'm going to be touching here, okay? And we're basically going to then unsolder this unit from this can. And if you'll notice, this can over here has a wafer around it, so it's being isolated from the chassis, and then the ground of the can is not sitting at zero or at ground, so we've got to float this capacitor by connecting it to the ground of this unit, and then we're basically going to perform the exact same feat we just performed here on this unit, on this capacitor. Okay, we can see our hum still sitting here. Let's start testing this other section here of the capacitor. Lo and behold, what do you see there? I want you to listen to this, okay? You ready? Hear the hum? Don't hear the hum, okay? And as I continue to play with this and kind of move it around to other sections here, I eventually get it to the quietest one. And what's happening here is we're actually, moving along the chain to get closer to the section that's bad, because one section being bad can affect downstream. But ultimately there, what I've found is inside this unit here, so I can get this in here for you a little bit, you can see now I'm just bypassing this leg over on this side with this 47 microfarad capacitor, and if you'll notice up here, whoa, sorry about that, on the oscilloscope we have nothing. If I reach down here now and remove this, we instantly have our little, and I'll connect it back on again, let you see one more time. as you can see, we've got a bad capacitor that happens to just be brand new. So let me flip the unit over and show you this capacitor, and we're going to end up ordering another one and replacing this. Forgive me, I'm going handy cam here, but you can see these are two brand new CP manufacturing. This is a CEX 50x4, which means it's got 4 sections of 50 microfarad inside of this unit right here, and this is our bad capacitor. So I'm going to have to get another one of these on order, get it replaced in this unit, and get the unit back to the individual. At any rate, I just thought it was an interesting little troubleshooting technique there that you may not see that often. Oh yeah, by the way, hidden up here on the top side are a couple more capacitors that had been replaced. But you kind of get the idea now of what we went through to figure out if we had a bad capacitor section or not. And honestly, I don't know a lot of other ways other than I could have pulled each of these capacitors out and then, you know, tried to use a capacitor tester of some type to test them. But what I kind of showed you was an in-circuit method of doing so. And as you can see, we've got the new capacitor here, 50x4. Going to install this one and get this unit back to the customer. I know he'll be happy to have his amp repaired, but it's just crazy, you know, brand new component that was installed probably 8 months ago, or something like that, has already gone bad. And so you can have that. Don't overlook the not so obvious. Sometimes it can be part of your problem. Alright, thanks for watching, everybody. Hope everybody's doing okay during this corona scenario we've got going on right now. So everybody please stay safe, and hopefully we'll get back to making some more videos for you here soon. Thanks for watching, everyone.